Hello everyone, I'm Varsha studying Computer Science and Engineering in Sri Venkateswara College of Engineering. Today's video is about operating system. Introduction to CPU scheduling algorithm. This session introduces to the concept of CPU scheduling algorithms which are essential for managing the execution of processes in a computer system. Round robin CPU scheduling algorithm. It is a simple, easy to implement and starvation free as all processes get a fair share of CPU. One of the most commonly used techniques in CPU scheduling is core. It is preemptive as the processes are assigned CPU only for a fixed slice of time at most. The disadvantage of it is the more overhead of the context switching. Explanation of turnaround time and waiting time. Turnaround time refers to the total time taken to execute the process, including both waiting time and execution time. Waiting time, it indicates the amount of time a process spends waiting in the ready queue before getting the CPU executions. Step-by-step stimulation of round-robin algorithm. Step 1. Process arrival. Processes arrive in a ready queue with their required CPU burst times. CPU allocation. CPU allocates a fixed time slice to process in the cyclic manner. Process execution. Processes execute based on the assigned time quantum until compilation. Calculation of turnaround time and waiting time for each process. Turnaround time. Process is 120 milliseconds. Waiting time. Process 115 milliseconds. Turnaround time. Process 235 milliseconds. Waiting time. Process 225 milliseconds. Comparison of round robin with other scheduling algorithms. Round robin ensures fairness in distributing CPU time among the processes but may lead to higher waiting times. First come, first served. FCFS prioritize the order of the arrival, leading to the potential longer average waiting times. Shortest job first minimizes the waiting time but requires precise knowledge of CPU burst times before the forehand. Conclusion and key takeaways. Efficiency. Round robin ensures fair execution but requires careful consideration to minimize waiting times. Trade offs. Choosing the right quantum balance is crucial to optimize CPU utilization and responsiveness. Real world application. Understanding scheduling algorithms is vital for designing efficient and responsive computing systems. Overview of round robin scheduling algorithm. Conceptual understanding. Round robin is preemptive CPU scheduling algorithm that assigns the fixed time until each processes. Implementing round robin, it cyclically schedules the processes based on the time quantum, ensuring fair execution of the task. Advantages and limitations. Round robin provides a good response but may suffer longer average waiting times. Advantages of round robin CPU scheduling algorithm. There is a fairness since every process gets equal share of CPU. The newly created process is added to the end of the ready queue. A round robin scheduler generally employs time sharing, giving each job a time slot or quantum. While performing round robin scheduling, particular time quantum is allocated to different jobs. Each processes get chance to reschedule after particular quantum time in this scheduling. Disadvantages of round-robin CPU scheduling algorithm. There is a longer waiting time in response time. There is a low throughput. There is context switches. Gantt chart seems to come too big. Time-consuming scheduling for a small quantum. Program for turnaround time and waiting time. Find waiting time of processes NBTW. Make a copy of the burst times to keep the remaining burst time. So remaining burst time is equal to 0 star n. For I in range, remaining burst time is equal to burst time. T is equal to 0, that is the current time, while true, done is equal to true. For I in range of n, if burst time is greater than or equal to 0, done is equal to false. If remaining burst time is greater than quantum, uh, T plus is equal to quantum. Remaining burst time minus is equal to quantum, else T is equal to T plus remaining burst time. Waiting time is equal to T minus burst time. Remaining burst time is equal to 0. Done is true, break. Define turnaround time. Processes B, T. For I in range of n, turnaround time is equal to burst time plus wait time. Find the average time processes n comma burst time comma quantum. Wait is equal to 0 star n. Turnaround time is equal to 0 star n. To find the waiting time, processes n b burst time, wait time, quantum, turnaround time of process n comma burst time comma wait comma turnaround time. Total wait is equal to 0. Total turnaround time is equal to 0 for I in range of n. Total wait time is equal to total wait plus waiting time of I. Total turnaround time is equal to total turnaround time plus total turnaround time of I. So printf processes burst time, waiting time, turnaround time for I in range of n. So print the average waiting time and turnaround time. And so example usage, if name is equal to main, so process IDs, processes is equal to 1 comma 2 comma 3 n. Length of processes, burst time of all processes, burst time is equal to 10 comma 5 comma 8 time, quantum is equal to 2. Find the average time processes n burst time quantum.